Hello, and today's learning target is I can classify real numbers. Let's first talk about perfect squares. It is so important that we learn and memorize these perfect squares. Once they become so much easier for us, it's easier to do lots of equations and solve problems. So let's first talk about these perfect squares. So let's recap. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225, 16 squared is 256, 17 squared is 289, 18 squared is 324, and 19 squared is 361. 20 squared is 400. Now, let's look at square roots. So let's think about the opposite. So when I take the square root of something, what's that answer? Well, the square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. And square root of 144 is 12. The square root of 169 is 13. Square root of 196 is 14. Square root of 225 is 15. Square root of 256 is 16. Square root of 289 is 17. Square root of 324 is 18. Square root of 361 is 19. And square root of 400 is 20. So when we take the square root of a perfect square, we get an integer or a whole number, right? So what do you think happens when we take the square root of a non-perfect square? So for example, what if we have the square root of 26? Well, we know that 25 is a perfect square and the square root of 25 is 5. And then the next highest perfect square after 25 is 36. And we know the square root of 36 is 6. So you might think that the square root of 26 is somewhere between 5 and 6. And what lies between two integers like 5 and 6, you might think of decimals or even fractions, and we will get a decimal answer here. So we can write down here what happens when we take the square root of a non-perfect square. It doesn't come out evenly. And I'll say it doesn't result in an integer. When I say, come out evenly, it doesn't become an integer. It doesn't become a whole number, we should say. And if you have forgotten what an integer is, we are going to talk about that again here in just a few minutes. And so we're going to talk about classifying numbers. So what category does each type of number fit into? So let's start looking at a few definitions. So, real number. When you think of a number, what do you think of? Well, you've probably thought of all types of numbers, such as fractions, decimals, or integers. And so for this definition here, we can say a real number is all fractions and I'll actually cross out the word and I'll say fractions, decimals, and integers. That you have ever encountered. So some examples could be, like negative 2.5 or negative 2, let's say, and let's say 5, or 0.3 repeating, or 0.5, right? Or we could even say 1/2 in place of 0.5. Pi, like that. those are all real numbers. They all exist and they're real, and they include negatives, positives, decimals, fractions. All of those are real numbers. An integer is a whole number and their opposites, so negatives and 0. So that's what an integer is, and we've talked about integers before, but just a concrete definition. So some examples include -10, -5, 0, 3, 8, 18, 218. All of those would be integers. A rational number is any number that can be written as a fraction, and it can include integers, decimals that end, and repeated decimals. So let's fill in this definition here. Rational numbers is any number that can be written as a fraction, and it includes integers, so the last definition we covered, decimals that end, and when I say decimals that end, another word for that is called terminating decimals, and repeated decimals. So it's kind of tricky to think about. So it's decimals that end, but also decimals that repeat in a particular pattern. So when I say repeat, that can go on forever, but it's in a pattern. So some examples include 0.5, that's a decimal. It can also be written as a fraction, 1/2. 18, that's an integer, that's also a rational number. -24, it can also be negative. 0.3 repeating, okay, because that's a repeating decimal. Or I could say 0.45 repeating, where the 4/5 continues to repeat. Or I could say, even 0.75, so again, a decimal that ends, a terminating decimal. -2/3, so a fraction. All of those would be considered rational numbers. Now, irrational, that's the last category we're going to talk about, are numbers that cannot, so I'll write here, cannot be written as a fraction numbers that cannot be written as a fraction, or they're decimals that do not end or repeat, so opposite of a rational number. So decimals that do not end or repeat. So an example, and one that we most commonly know as irrational, is pi. That goes on forever and no pattern, just continues on forever. Square root of 36, or 26, 36 is a perfect square. 26, because that does not come out evenly, right? We know it's going to be between 5 and 6, but it'll have a decimal, but we don't know exactly what that will be, so it will go on forever in no particular order. And square root of 2, because that does not come out evenly. And I could say negative square root of 5, because square root of 5 does not come out evenly, so we could also add a negative in front of it, because irrational numbers could also be negative. So now let's looking at classifying the following numbers. So let's look at 5. 5 is a real number. It is also rational, and I like to think of rational numbers as the clean numbers, where irrational numbers are like the ugly numbers. So 5 is a real number. It's also rational. It is also an integer. And it is a positive 5, so it is a whole number. And again, whole numbers are only positive. Those do not include negatives. And again, we talked about whole numbers a little bit when we spoke about integers. And again, integers can be negative and positive, but whole numbers are only positive. And now let's look at -4. So -4 is a real number. It is also rational. Again, it's that clean number. And it is an integer, but it is not a whole number because it has a negative. So it's not a whole number. All right, let's look at pi. And pi is a real number. Whoops. And it is also irrational because it goes on and on in no particular order. And since it's irrational, it is no longer in any other category. It's not an integer, it's not a whole number. If it's irrational, it's only in the irrational and real numbers category. Square root of 43, does that come out evenly? No, we know it's going to be between 6 and 7, but it's going to have a decimal. So this is a real number, and it is irrational. Square root of 49 is also a real number, and we have seen a theme with all of these, that they're all real numbers because they all do exist. But the square root of 49 does come out evenly, so that would turn into 7, right? So that's a real number. It's also rational. It's also an integer. And it's also a whole number. And that was just some practice on classifying the following numbers. Thanks for listening. Have a great day. Bye.